Hello everyone, I'm Samir. So today we are going to solve this problem, find all groups of farmland. So what is given in the question is there is m cross n binary matrix where 0 represents of forested land and 1 represents farmland. Okay. Now these lands are grouped together, and how they group together is vertically and horizontally, which means this will be considered as one group and this will be considered as second group, and they won't be connected diagonally. Okay, that's why these are two different groups. And what is asked in the question is like for each group of land we need to find the top left coordinate from where the land start and the bottom right coordinate from where the group of land ends. Okay, and there is one more important note given over here is like there this particular group of lands are designated in a rectangular areas. Okay, which means it will never be a case where there will be a 0 over here, because it won't form a rectangle if there is a 0 over here. Okay, so yeah, that is the question. So go through this question once, and after that we will discuss on the approach and the C++ solution of it. Yeah, so I hope you have went through the question. Now to discuss on the approach, what we can do, first we will iterate each cell, and if that particular cell is visited, if it is not visited and it is marked as a land area, then we need to do the search in that particular land. Okay, and let me explain. I have created a whiteboard over here. Okay, so whenever there is a search, only there we can do two types of search in graph. One is DFS and another is BFS. And over here, if suppose this is a land and we came across this cell, and this particular cell is not visited yet, then if we use the DFS, then the problem is like we don't know the flow, how it's going to visit its neighbor. Okay, so it can go like this. Okay, this way the DFS can resolve all the elements, and yeah, so we don't actually know the flow, and we can't work with DFS over here. But if we use BFS, let's say, in BFS we know that all of its neighbor are visited once. So first this is visited, then its neighbor, this will be get visited, then their neighbors, so this will get visited, and then this will get visited, and at last this will get visited. So what we can see over here while using BFS, first element will be our top left corner element and last element will be bottom right corner element. Okay, so we can directly use BFS over here to search over the grid. And yeah, whenever we visit any other unvisited element, then again this we have to do BFS search and add this top left corner and bottom right corner in our solution array. Yeah, so I have solved this question, and this is the C++ code I have written for it. Okay, we will be returning this two-dimensional array as mentioned in the problem. Okay, this array where it will have the coordinates of top left and bottom right corner of each group of land. Okay, and this we have created an answer array which we will be going to return over here. And I have to keep the track whether the element is visited or not, I have created this two-dimensional boolean array, and it is named as visited. And so I have a few other variables as well, where is this is m or n, which is number of rows given in this particular land matrix, and n is number of columns. So those are also initialized over here. Now what I will do is simply I will iterate through each elements in the grid. Okay, so I will iterate in this order, then this, then this. Okay, then if it is not visited and that particular area is land area, then I will make a BFS call over here, and I will pass the coordinates and the land and visited array. okay, and this BFS call will return the particular top left and bottom right corner for that particular group of land, and we will push that in the answer array. So one by one, whenever we visit a particular unvisited and land area, then we will push this particular coordinates in our answer. So first this will get pushed, and then these two elements will get pushed in our answer array. Yeah. So implementation of this BFS is like this. As soon as soon as we go into the function, I have created this land corners area like a vector, and it will have the coordinates of top left and bottom right coordinates. So first two elements will be top left coordinates, and last two elements will be bottom right coordinates. And and this is the implementation of BFS, and at last I will return that particular land area. Now let's dive into this implementation. So I have initialized a queue, and I have pushed the initial element which is passed over here, okay, in the BFS function. And as soon as I push an element into the queue, I need to mark it as visited, so that I don't push it again whenever it comes in a iteration. So till the time while the queue is not empty, I will extract the first element from the queue, and I will pop it out, and all the elements which are neighbor of it, I will push them into the queue. So how do I know which are the neighbors? So I have created one moves array, okay, and I have put in the set of 4 elements, okay, 4 coordinates, which will help us to move from particular cell to its neighbors, okay. So this set I have created. Now I will iterate through each of these elements, and I will simply add it to the respective coordinate, x coordinate and y coordinate, and I will check if that particular coordinate is valid. Then if it is not visited and that particular area is land area, then again I will push it into the queue. I will mark it as visited, and now this particular coordinate is like our possible answer. So I will put that in the last 2 elements, okay. So yeah, so at the end what will happen, this coordinates will get override every time, and whenever so here it is getting overrided with this, then it will get overrided with this, then one by one they will get override, and at the last element will get override in the last, okay. So that will be the bottom right element. Yeah, then I will return this particular array from the function, and it will get pushed into the answer, and at last we will return that particular answer. Now over here I am checking whether the element is valid or not. So this is a simple function where we are checking whether the element is inside the particular matrix or not, okay. If it is inside the particular matrix, we are returning true, otherwise we will return the false, and this is the condition for checking that it's the x should be greater than 0, and x should be the less than number of rows, and y should be greater than 0, and y should be number of columns, okay. And that's it. If you like this video, then do give it a thumbs up and subscribe to the channel. I will paste the link of this particular code in the comment section. Okay. Thank you.